In this video, we are going to be looking at standardization of LPP. LPP means linear programming problem. But before we go into this standardization of LPP, I would like us to look at the definition of three terms. The first term is slack variables. Slack, as in S-L-A-C-K. When I talk about slack variable, we are referring to a variable that is added to the left hand side of the constraint whenever the inequality is of less than or equal to. So we have, like here now, we have all this inequality here to be, we have it here to be less than or equal to, less than or equal to, less than or equal to at the left hand side. So this simply means that we are going to be introducing slack variable in this question 1 here. So, and for the 2 now, there's also something called the surplus variable. We have what is called surplus variable, and a surplus variable is introduced when the inequality sign is of greater than or equal to. When the inequality sign is of greater than or equal to, we introduce the surplus variable. Like here, we are going to introduce a surplus variable here, we are going to introduce a surplus variable here, and we are going to introduce a surplus variable here. And also, the third thing I want us to look at is the artificial variable. Artificial variable. Now, we include an artificial variable when the inequality sign is of equal to sign or is of greater than or equal to. So when the inequality sign is of equal to or greater than or equal to, we are going to introduce our artificial variable. Like here, we are going to introduce an artificial variable here. Even here, we are going to introduce our artificial variable. We are going to introduce it here, and we are going to introduce it here. So let's see how this goes. So right, another concept I would like us to understand is I would like us to get familiar with basic terms in LPP. So let's consider this. This here is what we refer to as the objective function. This is the objective function. This is also the objective function, and this is the objective function. And these are called your constraints. These are called constraints. And these are called non-negative condition. Non-negative conditions. That's why we have greater or equal to 0. x1, x2 is from greater or equal to 0. So it's a non-negative condition. It must be greater than or equal to 0. So the same thing here applies for every other example here. So now we are going to jump right into our solution. Alright, so we are to standardize this LPP solution. So making use of our slack variable, a surplus variable, and artificial variable. Now, number 1 here, we are to maximize z equal to 3x1 plus 2x2. We are going to still repeat that. Max z equal to 3x1 plus 2x2, and this is subject to the first one here. We have it to be 4x1 plus 3x2. Now I told you that if it's less than or equal to, you introduce your slack variable, which is plus s1. Let s1 represent your slack variable, and this, we turn this to equality sign, it will be equal to 12. So for the second one here, we have 4x1 plus x2. This will also be plus s2 now, which will be equal to 8. For the third one, we are going to have to be 4x1 minus x2 plus s3 which will be equal to 8 as well. So now our non-negative condition will be x1 comma x2 comma will now include our slack variable s1, s2, s3 all greater than or equal to 0. So that is how to standardize this LPP. So let's move to the second one. Let's see how we can standardize the second LPP. We are to minimize this time. We are to minimize z equal to 4x1 plus x2 subject to 3x1 plus x2. Now we have equal to here. Now remember, we are going to now include our artificial variable a1 equal to 3. Let a1 stand for the artificial variable. So going to the next one, now we have 4x1 plus 3x2. We have greater than or equal to. So remember, when we have surplus, the artificial variable artificial, I said we include it when we have greater or equal to or equal to. So we have greater than or equal to here. So we are going to include our artificial variable and we are going to include our surplus variable. So including artificial variable, we are going to have it to be we'll minus surplus, which is s1, then we add artificial variable a2 since we have a1 already, and this is going to be equal to 6. So the next one here we have x1 plus 2x2, then this is less than or equal to, which is going to make it the slack variable, which is s2 this time since we already have s1, and this is going to be equal to 3. So our non-negative condition is going to be x1 comma x2 comma a1 comma a2 comma s1 comma s2 greater than or equal to 0. So we are finally standardized example 2. So let's look at the third example straight up, where you are to. So before, I've omitted something. Now when we are standardizing when we are standardizing a minimization and a function here, we are going to include this. We are going to include a1, the first a1 here. We are going to include this, and we are going to include minus s1 plus a2 plus s2. We include all these slack, surplus, and artificial variable to our basic function. We include it there. That is for minimization problem. That is only for minimization problem. You are going to include your slack, artificial variable, and surplus variable on the basic function. So that is that for minimization problem. So now let's look at the third example. And before I also move to the third example, I would like us to understand this. Minimization is equal to minus maximization. Minimization is equal to minus maximization. So this could also be written as, this here could also be written as max of z to be equal to minus 4x1 minus x2 minus a1 plus s1 minus a2 minus s2. So this and this are the same, so you could write them in any way you want to. So but this is now standardized. So let's look at the example 3 here. We are to minimize z equal to 4x1 plus 20x2 such that subject to 6x1 now plus 8x2, we have greater than here and equal to. So that means we are going to remember subtract our surplus variable s1 and include our artificial variable a1, and we equate this to be 100. So for the second constraint, we have 7x1, we have plus 12x2 greater than or equal to. The same, we are going to subtract x2, so plus I'm going to add an artificial variable. I will make it equal to 120. So the non-negative condition will now be x1 comma x2 comma a1 comma a2 comma s1 comma s2. I remember here now we are going to be adding our artificial variable and the rest here. We have minus s1 plus a1 minus s2 plus a2. So this is the standardized form. So example 4, we are to maximize 2x1 plus 4x2 plus x2 subject to this respective constraints. So as usual, we are to max z equal to 2x1 plus 4x2 plus x2, and then this is subject to, now we have x1 minus 2x2 minus x3, then we have less than or equal to, which makes it a slack variable, plus s1, and we equate it to 5. Then the second constraint, we have 2x1 minus x2 plus 2x3 plus a1, since is equal to there and we equate it to 2, we add our artificial variable. So on the third constraint, we have minus x1 plus 2x2 minus 3x3, then we are going to minus s2, which is our surplus variable, and we are going to add a2, which is our artificial variable, because of this greater than or equal to, and we are going to equate this to 1. So our non-negative conditions will now be x1, x2, x3, we have a1, we have a2, we have s1, and we have s2, and these are all greater than or equal to 0. So this is what it means to standardize an linear programming problem. Please like this video, subscribe to this YouTube channel, and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.